This video is about my first 3D printer. It's a model P802 from Tronxy. The 3D printer is a gift from the online shop gearbest.com, additionally a spool of filament was part of the deal. The printer comes as a kit that can be purchased for less than 200€. Included in that very low priced offer are some minor scratches in the surfaces of a couple of parts. Those of you that know my self-made machines will have recognized that I don't care about minor flaws like that as long as the functionality isn't affected. Furthermore, this is a tool for your workshop, not a sculpture for your living room. For the assembly needed and part of the kit are 4 hexagon tools, a pair of tweezers, a side cutter, a cross tip as well as a slotted screwdriver. Additionally, a 14mm and a 5.5mm wrench, or instead a gripper or an adjustable wrench should be in reach. All documentation comes on a SD card that is inserted in the USB reader. The text of the build instruction is a bit clumsy, but with the very good illustrations you should manage the assembly without many guesses. To me, the assembly is part of the fun. Furthermore, you get a deep insight into the working principle of a machine while getting in touch with all of its components. All motors and switches are connected with the main board through clamps and plugs, there is no soldering needed. Note the correct polarity of the screw clamps, or else you will destroy your printer immediately when powering it for the first time. Remember that red cables are always connected to the positive terminal of a DC voltage, black cables run to ground. The power supply has an output of 12V at up to 20A. The insulation of the screw clamps isn't sufficient, keep children and confused adults away from this machine. I used 2 of the cable supports to get at least a worse strain relief mechanism for the mains cable. The manufacturer should improve the design at this point. Leftover parts after the full assembly is part of the millennia-long Tinkerer tradition and gives a good karma. You can have a look at the full resolution pictures of my machine on my project page if you struggle with one or another step of the assembly. Check if all axes move smoothly from one end to the other when turned by hand, and if all cables are following that movement without rubbing against parts of the mechanics. The end switch of the vertical axis is adjustable by a long 3mm screw. Adjust the trigger height in such a way that the print head, named extruder, doesn't touch the base plate, named print bed. There is no power switch on the printer, thus a switchable socket outlet is advisable to turn the printer off quickly in case something goes totally wrong. Time for a first test run. You can operate the printer through 5 push buttons, here I'm selecting the positioning of the motors. You can move each of the motors to its end switch, or use one command to move all motors at once. If the cabling was done correctly, all axes will move to the initial position. Next, the print bed is covered with blue tape that is used to keep the object sticking on the surface while printing. Be careful to avoid forming bubbles or wrinkles, you must get a smooth surface. Next step is adjusting the mechanics, which doesn't make sense if your printer is on a buckled surface because the frame bends under load with ease. I have put my printer on a 60x60cm floor tile that is warp resistant and not inflammable. Filament printers create heat to melt plastics, thus those machines might catch fire if something goes totally wrong. Install a smoke alarm above your machine because print jobs take a long time to finish, which is why your printer will run unattended sooner or later. The vertical axis is driven by two motors running synchronously during operation. If the motors are disabled, you can also move only one of them manually by what the mechanics bends noticeably. That's why you must adjust the X-axis in parallel to the print bed first. After that you can start leveling the print bed. Move all axes, mainly the Z-axis, to their end switch by operating the machine with the LCD display. After that, turn all motors off. Move the extruder manually near to the corner points of the print bed and adjust the height of the base plate with the knurled nuts in several runs. Adjust a gap of approximately 2mm on all corner points in the first run. Reduce that gap step by step until no more than a sheet of paper fits between print bed and extruder nozzle. Cut off the first centimeters of the filament to get a pointed tip. Next thing to be done is feeding the extruder with filament. Preheat the extruder to the accordant temperature of your filament. As soon as the set point is reached, you can insert the filament by pressing the lever on top of the extruder. Keep that lever down and push in more filament until the plastics exits the extruder nozzle. As you can see, the left spindle moves while pressing the lever with the motors being disabled by what the adjustment of the printer is ruined, thus be careful when replacing the filament. Now the printer is prepared for its first job. Printing from SD card is supported by the firmware, which is a nice feature because otherwise your computer had to run for several hours until a job is done. Print bed and extruder are heated up before the printer starts a job. Besides the blue tape, the heated bed keeps all objects sticking on the base plate during printing. The job starts as soon as both temperatures are reached. Usually the printer deposes a strand of plastics around the print area first. With that you can see if all objects are arranged correctly on the bed. Furthermore, gas bubbles in the extruder nozzle are pushed out. All parameters such as print speed, layer height, extruder temperature and more are stored in the file on the SD card and sent to the printer as G-code commands. The print volume is 22x22x24cm and the layer height can be set from 0.4 to 0.1mm. Here I'm using 0.2mm layers. The lower the layer height, the smoother the surface becomes, but the longer a print job takes to finish. Even with the highest resolution you can clearly see the layered structure on the surface of a filament print. You can get full resolution pictures of the samples I'm printing on my project page by what you get a better impression of the quality of that prints. Furthermore, you can get more tips and tricks about 3D printing and the P802 printer on my pages. To my mind, 3D printers are great tools for getting quick results when building structures for prototype machines. I'm not the man that designs sculptures. Here I am printing gears. The advantage of 3D printers is that you can iterate a machine design quickly by simply changing bits and bytes in software. Especially when using electric drives, the optimal transmission ratio must be found to get the best out of the input energy. With a 3D printer you can build gears with any number of teeth, rapid prototyping at its best. The maximum extruder temperature of this machine is 275 degrees, by what you can process a variety of plastics with this printer. Here I'm using PLA, which is an easy to handle and so a common material used with filament printers. The extruder temperature is set to 200 degrees. Besides the good print results, PLA isn't very harmful to health, in contrast to rice plastics that more or less poison the ambient air during operation. The input power drawn by the printer ranges from 20 to 170 watts, depending on whether the heaters of extruder and print bed are turned on or off. The temperature of the power electronics on the main board is no more than 52 degrees, which is absolutely okay. While talking about temperature, the fan of the power supply, which is always turned fully on, is the loudest machine part during operation. After the print job is done, let the printer cool down before removing your prints from the bed. There are clearly visible gaps at the smaller gear wheel, which is not caused by poor printer quality, but by setting the wrong software parameters in the print file. Keep in mind that this was my very first software design and my first 3D print ever. The mechanics of the printer is based on the Prusa i3 that is published under the GPL license, and you can get many add-ons of the mechanics developed by a growing community. The fun in building the printer isn't over. You can use the machine to improve its design over time. With the P802 you get a working 3D filament printer for a very good price. If you don't mind assembling a kit, and if you have at least some base knowledge in electronics and experience in constructing, this is definitely worth buying. In March 2017, Gearbest.com celebrates its 3rd anniversary with special offers, but even when those days are gone, it's worth a click to get a very cheap starter kit that opens the world of 3D printing for you. Learning 3D printing means gaining experience, because many parameters affect the quality of a print. If you don't want to ruin an expensive printer when starting your own experiments, get a hand on this one. My second print of the 8-teeth gear wheel is clearly better. You can watch my progress in 3D printing on my project pages as well as in coming videos. Thanks for watching, and I'll be back.